In the last lesson, we wrote quadratics given key features, like their vertex and focus and directrix. Now we're going to actually use points that are on the graph to write the function. Now, hopefully you can remember back that if you had any 2 points in a coordinate plane, you could write the equation of the line. Because you would need your slope, and then you could graph it and find the y-intercept, or there's several ways to do it. But let's see if 2 points are enough to make a parabola. So let's start with the points 2, 0, and 5, 0. Well, let's think about where those 2 points are. 2, 0, and 5, 0. Well, that would be 2, 0 would be, see here, 3, 4, 5. So those are x-intercepts. Those would also be solutions if we set our function equal to 0. So let's think back, if we know the solutions, how we wrote the equation. Well, if we knew x equals 2 was one of the solutions, remember, that meant that we had a factor of x minus 2. And if I have a solution of x equals 5, then I had to have had a factor of x minus 5. And if I multiplied that out, I would get x squared minus 7x plus 10. Now this is an equation. It's not a quadratic function. The quadratic function would be if we replace the 0 with y. What this does is gives us every point that meets these conditions. So it would give us that whole parabola, not just 2 individual points. Now, could we verify that these 2 points are on this graph? Well, sure. We could plug them in. That was 2y. 2, 0 would be x, and 2 would be x, and 0 would be y. Sorry. So does 0 equal 2 squared minus 7 times 2 plus 10? Well, 2 squared is 4. That's minus 14. So that'd be a negative 10 plus 10. Yes, it does equal 0. And if I plugged in 5, 0 equals 5 squared minus 7 times 5 plus 10. Well, oops, we're not sure if it equals yet. We're having a question mark here. That'd be 25 minus 35 plus 10. Well, that's a negative 10 plus 10. It is 0. So those 2 points are on this function. Let's look at the graph of it. So I'm going to turn on the calculator. Y equals, clear out anything that's in there. We're going to go x squared minus 7x plus 10. If I look at the graph, notice it is going through those 2 points. So my little sketch over here is doing something like this. Right? Well, let's see what happens when we plot 2 other points. And if you look at the bottom of your screen, there's, 2 other functions. There are 2 other functions. Let's see what they look like. 2x squared minus 14x plus 20. Compare this function to the one we had written down. Now let's put in the next one. Negative x squared plus 7x minus 10. Does anybody notice the relationship? Let's start with the first and the second one. How do these 2 functions compare? Hopefully you see that everything is doubled. Then if we compare our first one with this last one, everything is opposite signs. But let's see what that does to the graph. There was our original. Ooh, that second one that was doubled, it is stretched. And the third one is flipped. So, we ended up with 3 equations that all go through these 2 points. So are 2 points enough No, because we have three equations that are going to three functions that are still going to the same 2 points. So we have to have 3 points. Now, they can't be in a straight line. That's not going to work. But we have to have 3 points. So let's consider a function who's passing through 1, 2, 3, 0, and 5, 6. Let's take each of the points and substitute it into the generic or standard form of a quadratic. That's y equals ax squared plus bx plus c. So if I take the point 1, 2, 1's going to go in for the x and 2 goes in for the y. 2 equals a times 1 squared plus b times 1 plus c. 1 squared is 1, and that means I'll have 2 equals a times 1. B times 1 would just be a b plus c. Let's take the next point. The next point is 3, 0. So 3 goes in for x, and 0 goes in for y. 0 equals ax squared. A times the x on this one is 3. B times x, so b times 3, plus c. 0 equals 3 squared is 9 times a. B times 3 would be 3b plus c. The next point, 5, 6. So 5 goes in for x and 6 goes in for y. 6 equals a times 5 squared plus b times 5 plus c. Well, that's going to be 25a. B times 5 is 5b plus c. Notice, we have created 3 equations with 3 unknowns. I think we remember how to work these. If we write them all down together, let's see what we have. And I'm going to take that first one, and instead of having it be 2 equals, I'm going to write a plus b plus c equals 2. Then I've got 9a plus 3b plus c equals 0. And the last one we wrote is 25a plus 5b plus c equals 6. So, if we remember back, when we had a system of equations with 3 equations and 3 variables, we paired them up to eliminate a variable. So we have to pick somebody to get voted off the island. Who needs to go? Ooh, I think I see one that's easy to get rid of. Let's get rid of C. All I have to do is make one of the equations negative, and we can get rid of C pretty easy. So let's take equation 2 and then make equation 1 negative. So equation 2 was 9a plus 3b plus c equals 0. And if I take the opposite of equation 1, make it a negative a minus b minus c equals negative 2, then I can add the 2 equations together. 9a and a negative a is going to give me 8a. 3b and a negative b is going to be 2b. The c's got eliminated. 0 and a negative 2 is going to be negative 2. Let's do the same thing but with equation 3 and then the opposite equation 1. 25a plus 5b plus c equals 6. Negative a minus b minus c equals negative 2. 25a and a negative a is going to be 24a. 5b and a negative b is going to be 4b. And then 6 and a negative 2 is going to be a 4. Now we have 2 new equations, and they only have a's and b's. So we can combine them to eliminate somebody else. Notice how close the b's are. If I took this equation and multiplied by a negative 2, let's see what happens. Negative 2 times 8a is going to be a negative 16a. Negative 2 times 2b is going to be a negative 4b. And then negative 2 times a negative 2 is going to be a positive 4. Let's add the two equations together. 24a and a negative 16a is 8a. The b's are gone now. And on the other side I have 4 plus 4 is 8. So we easily can get that a is 1. Now that you know one of the variables, we're going to plug it back in to any of the equations to find another one. Hey, that's a pretty easy equation to use. That equation was 8a plus 2b equals negative 2. Well, let's plug in a. A is 1. So that gives me an 8 plus 2b equals negative 2. Subtract 8 from both sides, and you get 2b equals negative 10. So b is negative 5. Up, 2 down, 1 to go. Which equation still has a c in it that would be easy to use? Ooh, I like equation 1. A plus b plus c equals 2. So we know a is 1, b is negative 5, and now all we have to do is solve for c. So negative 4 plus c equals 2, so c equals 6. So we have our a, we have our b, and we have our c. And remember, the standard form of a quadratic is ax squared plus bx plus c. So we're going to plug in what we know. Now we know what a is. That's going to be 1x squared. It's going to be a negative 5x and a plus 6.